Over time, the human body undergoes a vast number of changes, all differing in how they look and how they happen. One of these changes is our hair color. A person's hair changes color throughout their life, and with age, strands of hair begin to turn that distinct white color. Eventually, at a certain stage, all the hair turns white. But what's the real reason for this? What could possibly make our hair change color just because we get older? And more importantly, why do we see some people with white hair even though they're still young? Today we're going to answer the question, why does our hair go gray as we get older? Without further ado, let's begin. Anything with color needs a pigment to get that color. The exact same thing applies to the human body. The protein pigment melanin is secreted inside the body by cells called melanocytes. These cells are responsible for coloring everything in our bodies, from our skin tone and eye color to finally our hair color. But what's interesting is that the melanin pigment itself doesn't actually contain colors. For instance, it doesn't hold yellow, gray, or red pigments within it. The entire concept comes down to the concentration of the pigment. If melanin particles are densely packed in one area, they produce a certain color. If they are less dense, they produce a different color. This is what creates the variation in people's eye colors. The amount of melanin in the iris differs from one person to another, which in turn changes the color. The same process happens with our skin and hair. Hair is one of the things most closely linked to melanin. However, melanin isn't the only key component. There's another element called keratin. When these two elements combine and mix, we get hair. Every single hair on the human body consists of two parts. A part above the skin, which is the visible hair we see, and a part under the skin, which acts as the root from which the hair grows. Surrounding the lower part of the hair shaft are tube-shaped tissues, and the hair roots or follicles contain the pigment cells that produce melanin and give hair its unique color. Keratin helps to strengthen the hair and make it smooth, while melanin is responsible for giving it color. There are two main types of melanin. The first is called eumelanin, which helps produce brown or black hair. It's most common in people with darker or olive skin tones. The second type is called pheomelanin. This is what gives hair its blonde or red color and is common in people with fair skin. It's also possible for a person to have both types of melanin. Depending on the amount of each, the hair takes on a specific shade. For example, if eumelanin is dominant, the hair will be black. If pheomelanin is dominant, it will be golden blonde. And by combining the two pigments, we get brown, orange, red, and other shades. This brings up a question. If every part of the hair contains the melanin responsible for coloring it, what causes the color to change when the pigment is already there? The reason for the change in hair color is a change in what gives the hair its color. It's as simple as that. As a person ages, the pigment cells begin to produce less melanin. This is because the cells in the hair follicles produce a substance called hydrogen peroxide. This substance later combines with an enzyme called catalase, which works to balance the amount of hydrogen peroxide present. However, with age, the catalase enzyme begins to decrease. Consequently, the amount of hydrogen peroxide in the follicle increases and accumulates, causing what's known as oxidative stress. This, in turn, affects the pigment cells inside the follicle, preventing them from carrying out their function, which is to produce melanin. When the hair starts to lose its melanin, it begins to turn white. It's natural for older people's hair to turn from black to white for the reasons we've mentioned. But how do we explain the cases we see where someone's hair turns white while they're still young? For instance, someone can be in their 20s with a lot of white hair. The phenomenon of premature graying is largely dependent on genetics. The gene responsible for this is called IRF4, which plays a role in regulating the production of melanin in the hair. When certain genetic variations occur in this gene, the hair begins to turn from black to white at an early age, instead of following the natural timeline associated with getting older. However, genetics is not the only cause of premature graying. Another factor is stress and exhaustion. This is because stress plays a significant role in producing oxidizing substances in the body. As we mentioned, these substances affect the pigment cells that produce melanin, thereby increasing the likelihood of premature graying. A curious piece of evidence often cited for this is the comparison of photos of US President Barack Obama on his first day in office and on his last. The difference in his hair color and the degree of graying between the two photos is very striking. It's as if the stress, responsibility, and constant strain caused his hair to turn white in a shorter than normal period. However, this topic is still under study. What is certain about psychological stress is that it can cause hair loss and damage. Another cause of premature graying is smoking. Smoking in general contributes significantly to signs of aging and harms the human body. It follows the same path we described earlier, affecting the pigment cells in the hair follicles. A deficiency of vitamins in the body, especially B vitamins and iron, can also contribute to premature graying. That's why it's advisable to eat foods that can replenish them in the body. The strangest thing about premature graying is that it doesn't just affect young adults and teenagers. It can even appear in children who are only a few years old. There are many cases of a 4-year-old child, for example, having several white hairs on their scalp, and you might even find a full white streak in their hair. The appearance of white hair specifically in children can be due to vitamin deficiencies, or it could be a symptom of conditions like vitiligo, tuberous sclerosis, or anemia. In some cases, the cause is a problem with the thyroid gland, which can lead to a decrease in melanin pigment in the skin. Of course, we can't jump to the conclusion that a child has one of these problems just by seeing a white hair on their head. There must be other symptoms accompanying the graying to diagnose a medical condition. If a child has white hair but is otherwise healthy and not suffering from any issues, it's likely just a normal decrease in melanin and not related to any illness. So, if your child or a child you know has some white hair, it's not necessarily something to worry about. There are absolutely no fears or dangers from this if the child's general health is normal. A common myth is that if you pluck a white hair, more white hairs will grow in its place. This is completely untrue. Plucking a white hair does not cause more to grow back. The growth of white hair depends on the pigment cells in that specific hair follicle, stopping their function. This means that removing one white hair won't cause the one next to it to turn white simply because each hair is independent. Each one has its own roots and its own pigment cells. Another thing we often hear is that a sudden fright can instantly turn your hair white, meaning if someone is scared by a certain event, their hair will turn white. This is also completely false. Hair does not change color overnight because of a single incident, and no scientific study confirms this. However, it's possible that people have linked the idea of psychological stress and trauma to fright, since being frightened is a form of psychological stress. Repeated fright could affect a person's mental state, which in turn might affect their hair in one way or another. But the idea of hair color changing suddenly has no basis in reality.